Hi, Michael.
Hey, how's it going?
Good. How are you doing?
I'm doing very well. I'm very excited to be doing this, though. It's kind of funny if you think about it. Like you and I were both sort of application security people, right? I mean, our background is in like applications, and here we are talking about NSGs, network security stuff.
Actually, I'll have you know, I used to be a network engineer as well for a time, so I do love a bit of love a little bit of networking. That's the thing.
But actually, kind of the point I wanted to make there, though, is that the cloud's kind of interesting, right? Because if you even my background is application development security, right? That is what I do. That is my sort of my bread and butter. But in the cloud, you have to understand the basics of network security. In fact, I'll even argue or go one step further that if you're a networking person, you have to understand the basics of sort of app dev and app dev security and Git and CI/CD pipelines and infrastructure as code and so on. And so there's two worlds of sort of applications and networking kind of smushed together when it comes to cloud environments. So it's great to be talking about this specific topic, which is network security groups and service endpoints. So before we
Michael, before we go any further, do you want to introduce yourself to everyone? Because you and I know each other very well, and we could just chat, but we should probably say hello to the folks who are watching.
We should. Yeah. Thank you, everyone, for joining us. My name is Michael Howard. I've been at Microsoft now for 30 years, believe it or not. The one back there, the award at the back, you can see the big one is actually 25 years. I'm still waiting for the 30 year. And yeah, I've been doing all things security at Microsoft, and right now I'm in the Azure data platform. So I work on security for Azure SQL Database, SQL Server 2022, and so on, Cosmos DB, and all the other database products that we have. So Sarah, what about you? Why don't you give us a quick overview of who you are?
Okay, so my name's Sarah Young. I'm a senior cloud security advocate at Microsoft. I've been at Microsoft for not as long as Michael. I've been at Microsoft for knocking on 4 years now. I'm based in Australia, so it's the morning for me. Hello from the future. It's one of those really bad jokes that you can say because it is Thursday for me now. And I do lots of I've done lots of security things over the years, and both of us run. This is really weird to be doing something like on camera with you, because normally we just talk at each other, because we do a podcast called the Azure Security Podcast. There's a link on the slides, so some of you may listen to it. So it's really strange to be doing something like with a screen with you, Michael.
Yeah, so the podcast, we record every couple of weeks. We're into our 3rd year now, and we have that. We do that with Mark Simos and with Gladys Rodriguez. I really couldn't ask for a better crew. It's a great crew of people for doing the podcast. So with that, let's sort of move on to some other stuff. So both of us have written a couple of books. Why don't you explain the book that you worked on, and then we'll move straight on to the material.
Yeah, exactly. So real quick, I've done, and there's another one coming soon. I was a co-writer of the SC200 Microsoft Security Operations Analyst exam reference from Microsoft Press. I think at the moment as well, during Ignite, that MS Press have like a deal, some kind of Ignite discount code on the MS Press store. So if you were ever thinking of buying an MS Press book, now is the time to go do it. So it was written by Yuri and Jake as well. And the SC200 guide is, the SC200 exam is the Microsoft Security Operations Analyst. So it covers Defender for Cloud, Sentinel, and Defender for Endpoints. So if you're working on any of those products, that's probably something you want to have a look at. Michael, but yours is newer than mine. So.
It is. In fact, mine's coming out in December this year. We got Scott Guthrie to write the forward for it. We're really excited about that. But it's myself, Simona Kurtzy, and Heinrich Gantenbein. We just sort of we cover the whole gamut, from secure software development practices, container security, confidential computing, crypto, insecure code, threat modeling, the whole 9 yards, compliance. Really exciting. In fact, as of about 3 hours ago, we finally got the absolute final sign off on all the manuscripts. So that's going to the press today, which is fantastic. Let's move on.
Well, for those of you who don't know, because I didn't know this until for ages, but Michael's he originally wrote the first ever secure coding book like 20 years ago. I didn't know this for a long time. And then I was like, oh, wow, he's like a big deal.
Yeah, writing secure code. Yeah, it was a lot of fun. Yeah, 815 pages. It was 22 years ago. Yeah.
That's all right. Pretty insane. But anyway, we should get on with doing some learning.
We should. So our moderator today is Michael Bender. He won't be on this, on the transmission, but he's in the background moderating any comments that come in. So again, thank you so much for joining us. What we're covering today is essentially an online live version of one of our Learn modules, which is the secure and isolate access to Azure resources by using network security groups and service endpoints. The main learning objectives of this are to identify, what NSGs are and why they're important. Also, why virtual network service endpoints are important and kind of how they work. How you can use these things to restrict network connectivity, and then also how you can control the networking traffic flow from say inside your environment to keep the sort of the traffic within the environment as opposed to going out onto the internet. And that's for some customers is really, really important. From an assumptions perspective, honestly, is nothing. This is a 100 level session. This is just the basics. Although a couple of points will get a little bit technical, but we really don't expect anyone to really know anything before we sort of plow into this material.
No, and please ask questions in the chat as well. Michael Bender is doing a wonderful job and will be answering them. But if he can't, or it's something that we're getting a lot of questions on, we'll answer it live on here too. So please ask all the questions you can, because NSGs sound simple, but there are no stupid questions. Don't be shy. Come and ask us things.
Yep. Everyone has to start somewhere, right?
Mm-hmm.
All right. So network security groups, NSGs. So the scenario we have here is you're basically part of a project to move an ERP. Hey, remind me again what ERP stands for. I never remember.
Enterprise Resource Planning.
Okay, there we go.
So most businesses will have an ERP system. Okay. They're quite important.
Okay. So, you're moving some system. Actually, if it was me, my sort of prior life working with in consulting, an architect with customers, I'd be moving like a healthcare system, for example, or parts of a healthcare system to our cloud. And, ultimately, when it comes to designing these things, you really have to think about all sorts of defenses. And one of them, just one of them, is network isolation. And network isolation is kind of really important because, the public cloud is the public cloud. That keyword at the beginning of public is really important. And sometimes you want to be able to restrict the network access to various resources in your environment. And that's why we're talking about network security groups. And we're going to be talking about other mitigations as well. And on that topic, NSGs are just one way of isolating resources at the network level. One big example and very well-known one is the Azure Firewall. And so you often see this being used in, say, hub and spoke environments where traffic comes into a hub, there's a firewall, and then it does all the packet inspection, whatever it needs to do, and then routes it off to the appropriate spoke to get the work done, where you may have different applications in different spokes. There's also things like PaaS firewalls, platform as a service firewall. So, for example, Azure SQL Database, Cosmos DB, these are all PaaS solutions, and they all have their own firewalls. Now, notice I spell the word firewall here with a lowercase f, because it's not a full-on firewall. Like, we're not doing low-level packet inspection and looking for bad packets and looking for malware, right? This is essentially a filtering mechanism to filter by.
So, we had a full-on discussion about this yesterday, didn't we, Michael? So the deliberate placing of the not a capital letter.
Yeah.
But you will what you will notice though is that in PaaS services, it's usually you just go into the UI and there'll be probably a couple of boxes to check more than it being a separate entity. So it is an important distinction to make. And I think as people go more cloud native and hopefully people use more PaaS things because ideally we're trying to, if you can, move away from virtual machines and IaaS where possible, we'll probably see more of those PaaS firewalls as well. Make the cloud provider do the work. Yeah,
exactly. So that's why we spell it with a lowercase f, because it's not like a full-on massive, firewall with all this low-level stuff going on. Then there's network security groups and service endpoints, which we will talk about in this session. Next one after that is private endpoints. We will not talk about private endpoints. This is literally its own other topic. It's a big topic. Yeah. It's a very complex topic. There is a link there to the training if you want to go and look at it. And finally, there's user-defined routes. Technically, user-defined routes are not really an isolation technique, but what they allow you to do is route certain packets to certain locations, say for packet inspection or for, you want some stuff just to die, right? Basically black hole traffic. And so that's what user-defined routes are all about. But we won't be covering those. We're only going to be covering these two, which is network security groups and service endpoints. So please, make sure you're aware of that. The learning path is just these two, and that's exactly what we're going to be looking at.
I'm going to ask you a question, Michael, before we go any further, though, because I've been asked this question before. And what for those of us, because I'm sure there are people who are brand new to this, and it's important. What is the difference between like Azure Firewall and an NSG? Because
so an NSG is really just part of the low-level networking infrastructure that's built into Azure, whereas a firewall is actually a product, right? It's a feature that you can purchase and you can subscribe to and use in your environment. And the Azure Firewall, as an example, and there's other third-party firewalls as well, will do very heavyweight packet inspection, perhaps even termination of sessions and so on. The network security group is literally it's almost like a little traffic cop, right? Just to sort of redirect traffic or even block traffic. But that's basically, it's very, very simple and relatively straightforward to use.
So we're not saying here then, just to clarify, we're not saying that NSGs are a replacement for firewalls, because I've definitely had that discussion with customers in the past.
Yeah, and actually that's another thing you sort of alluded to is Azure Firewall, or any kind of firewall for that matter, is really kind of an edge device. 9 times out of 10, I mean, you can use them inside of a network as well, but they're often an edge device that you have. NSGs are not a device, right? It's just something that's part of the networking layer in Azure.
And it's also love to throw in a buzzword, though I'd say it's not a buzzword anymore. This is a really good way if you're looking at doing zero trust, which everybody should be. This is the network side of zero trust. So the scenario we're looking at is only enabling this ERP system to connect to specific endpoints. That is zero trust at the network level. An entity, an asset, whatever it is, can only talk to exactly what it needs to talk to, even internally within your network. Because what we used to do, right, was we'd say, oh, it's all internal, it's in the data center, everything can talk to everything because we trust everything in there. Right. And we're moving away from doing that. And NSGs can really help with that.
Yeah, and in fact, to add a little bit more sort of color to that, if you take zero trust, one of the elements of zero trust is to assume breach. And so, if we're assuming breach, what happens next? And if the answer is, well, the attacker has unfettered access to absolutely everything because there's no network, filtering, that's kind of bad, right? So let's focus on how we can restrict traffic and isolate things so that, there's no sort of overflow and, splash damage. An example, a scenario that I like to give is an old boss of mine was a submariner. And he said, the reason why submarines have so many bulkheads is because they assume they're going to get breached, right? But it's better to lose a part of a submarine than lose the whole submarine. And that's exactly what NSGs are. They're sort of like a bulkhead between environments so that you can restrict and control network traffic flow. So very, very important technology. Everyone should understand NSGs, everybody.
Yeah, I agree.
So on that topic, what is an NSG? So first of all, NSG is basically a set of rules, and I'll go through what these kind of rules look like in a moment. You can apply an NSG either at a network interface, so for example, on a VM, on a VM's network interface, I should say, or on a subnet. That's where they reside. You can do them on both. The preference is to put them on a subnet, and the reason for that is you usually have more than one thing inside a subnet. Actually, while we're on this topic of sort of isolation and so on, one thing you should be aware of in Azure is that the virtual network, the VNet, is an isolation boundary. Two VNets, unless you peer them, two VNets cannot talk to each other at all. Again, unless you peer them, which we're not going to talk about today. But they are an isolation boundary. But subnets can talk to each other, but you can control traffic flow between those subnets, which is where NSGs come in. And because you can have more than one service inside of a subnet, it's normal to put an NSG actually on the subnet as opposed to a virtual machine NIC network interface. But you can do
allow you to do both, right? Yep. Though our recommendation as Microsoft is that you tie an NSG to a subnet, because it starts to get real complicated and difficult to manage if you don't.
Yeah, and actually under the covers, the implementation is identical, whether you do it on the NIC or you do it on a subnet. It's basically identical. But here in this example here, we've got an NSG rule that's being applied to this subnet. We've got a VM communicating in and out. So this particular NSG, I'll go through what goes into an NSG in a moment, applies. But here we've got one on this specific VM. So whatever the rules are in here apply to this specific VM and not this one over here. And of course, you could also have both, right? In which case you could get into all sorts of problems if the NSGs don't sort of align properly. So that's why, for the most part, we prefer people to put NSGs on the subnet. So what makes up these security rules? So an NSG is really an ordered list of security rules. And by order, we mean by priority. So first of all is a unique name. So for example, allow HTTP traffic between ERP and storage account, something like that. Priority is between 100 and 4096. It can be higher than that. In fact, there are some defaults that are added higher than that. In general, I would always leave 100 free in case something catastrophic happens and you want to block traffic immediately. Because you can actually literally put a rule in there at 100 that says deny all traffic. You could do that. Then you put the source and the destination in there. So this is, source, which could be star, could be anything, or it could be a CIDR range, block of IP addresses, or it could even be just a single IP address. It could be a thing called a service tag, which we'll talk about in a moment, or it could be an application security group, which we'll also touch on in a moment. Protocol could be TCP, UDP, or actually it can be ICMP as well. I'm not sure why that's not in there, but it can be ICMP as well. So if you're familiar with ping uses ICMP. It doesn't use TCP or UDP. And then the direction, is it an inbound rule or an outbound rule? We have both sets of rules, and they can be set independently. Now, this is an important point. NSGs are actually stateful, so which means that if you have an outbound connection and then an inbound connection, a response coming back in, you don't need to have like an outbound rule and then go and do something funky to an inbound rule. You don't need to do that at all. We honor that by being stateful. So, to be honest,
I think, is it fair to say, Michael, if you've done traditional layer 3, layer 4 firewalls in the past, like this NSG stuff should, like what we're talking about here, should be familiar with it, no matter what brand or make you've been doing.
Yeah, I think anyone with a basic understanding of ports and protocols would understand this, but certainly if you come from a firewall perspective, absolutely. Yeah, absolutely.
Yeah, and those priorities as well, it's the same thing, right? We work down the list of priorities, and when there's a match, stops processing. So that's very similar, well, with almost identical behavior to firewalls in the past as well. So
yeah, now here's a little trap for young players while we're here. I've seen some tools dump the contents of an NSG in the order in which they were created, not ordered by priority. So be very, very careful. Make sure that they're ordered by priority, because if not, you may see things like you said, right? You may see things that are not in the correct order, and once the order is, if a request is satisfied, then the NSG is no longer analyzed. So make sure you're looking at things by priority, because again, some tools might dump by order in which they were added. The rules were added to the environment, which is probably not what you want. So just be aware of that. And again, as I mentioned, it's inbound or outbound. You can also set an individual destination port and source port ranges. And finally, whether to allow or deny. You can set either of those two. There are some default security rules that are added automatically. The first one is allow VNet inbound. This basically allows stuff within your VNet to talk to each other. Without this, you would be in a world of hurt. Next one is the allow as your load balancer inbound. This is for VM traffic. This basically allows your VMs to talk to the load balancer if you have the load balancer, including the heartbeat, to make sure your VMs are alive or not. And then the last one is basically, hey, if all else fails, then just block everything. So this is an example of closing. If this wasn't there, then traffic might be allowed. So this is an example of just shutting everything down if we don't have a rule that's explicit or explicitly satisfied in the list of NSGs.
Well, this is like the old school, because this is when I was learning networking, like, well, not as old as you, Michael, but like 12 years ago. I had to do it. But when I was learning networking, probably about 12, 13 years ago, we had I was taught that right at the bottom of firewall rules, you have deny any. So, so there is an explicit deny at the end, right at the bottom, because you don't want it higher up because it breaks things. So it's basically the same thing, right?
Yeah, I mean, if you had a 100 rule that was deny any, there'd be no network traffic at all,
Yeah.
because it would satisfy, if it would satisfy that rule immediately. So yeah, that's why this is in the very back, the very back, so to speak. There are also augmented security rules. Again, I sort of touched on this, but you can have IP ranges. You can have, by the way, it can be IPv4 and IPv6. You can have these things called service tags. And we'll talk about service tags in a moment. Actually, service tags are actually pretty cool. And then application security groups. These are all there to sort of make things a little bit easier for you.
Augmented is a funny name, though, isn't it?
It is a funny name. Yeah, I don't know why it's called Augmented.
Say, I know what they do, but I don't think the name is super obvious just by reading them what it does.
Yeah. To me, it's things like, grouping of security rules, or I don't know. You're right. Anyway, they call it Augmented, and that's what's in the notes. So and in the online training. So it is what it is.
For anyone who it's not, so everyone's like, if anyone's like, what does that mean? It just means sort of managing multiple things together, right?
Yeah. And actually, to be honest with you, the really good example is service tags. Like the really good example is service tags, which, funny enough, is the next topic.
Going on to.
So service tags are really, really cool. They allow you to say, I will allow communication inbound from Cosmos DB. You don't need to know the IP address ranges. You don't need to know them. Just say Cosmos DB. In fact, you could even go Cosmos DB US South, US South, South Central. So you could even restrict it even further. But the thing is, like, any Cosmos DB in South Central could then communicate with whatever the resource is that you're talking about. So examples include things like this. There are plenty of these things. But so, for example, you could say have a service tag for and let's pick one here as a storage, right? So I can say, I can allow outbound traffic to storage. You could go, I allow outbound traffic to storage in again, South Central or something like that. And if the IP addresses change underneath you, it doesn't matter. Your rules are still completely valid. You can get a list of those service endpoints. Sorry, those service tags. If I go here, here we go. There's a little website. You can actually bring a list of them all down. And as you can see, there is a whole bunch of them. So if I take, I don't know, let's keep going. Let's go to like Cosmos DB. A quick look, Cosmos. Here we go.
Your favorite.
Yeah, my favorite.
Not that you're biased.
Not that I'm biased or anything, but here's a whole bunch of the public endpoints for Cosmos DB. And
they're all just contained within the tag, right?
Correct. So if you just say Cosmos DB, and let's say someone adds a new IP address here, you'll still work, right? It'll still just work. And in fact, if I keep going, here we go. There you go. Actually, this may even be your neck of the woods.
Oh, there you go. That's
Australia Central. Yeah. So these are the IP address ranges, including IPv6 for Cosmos DB Australia Central.
So would it be fair to say that actually just using the tags is, I think for the majority of folks, is probably a lot easier than trying to look up. I mean, it's going to save you a lot of work, right? Trying to find public endpoints. Blah, blah,
yeah,
blah,
you
blah.
should never go really dealing with public endpoints. You really shouldn't. When I say public endpoints, I mean public Azure endpoints. You really shouldn't.
Yeah.
Because they may change underneath you. Whereas the service tags, well, it's like the old adage in computer science, right? It's every problem can be solved with another level of indirection, and that's exactly what this is, right? So this is what service tags are. So remember, it's not just like Cosmos DB. It could be Cosmos DB Australia Central, or East US East 2 or something like that.
I guess another thing to call out there, if we look at storage, just on the bullet point above, though, there are some limitations on service tags, so make sure you read what they are. So you can see for storage, we can limit to a specific region, but we can't select an individual storage account. So
that is correct.
If your security posture and your risk tolerance is very, very strict and you're going hard out zero trust, maybe the service tag might not work. But equally, you have to balance that with thinking about, the amount of maintenance if you don't use of the rules, if you don't use the service tag. So something to think about.
Yeah, but you can restrict by using other networking isolation technologies like service endpoints to specific service accounts, to specific storage accounts, right? This is a broad brush, so to speak. So
we could be here for the rest of the day. We could be here for the rest of the day talking about all the different things we could do.
So the other cool thing about network security groups is they have a thing called application security groups, which you can apply primarily to a VM or a cluster of VMs. These are actually really cool when you think about it. So imagine you've got a scenario where you've got, and to be honest with you, this diagram doesn't really show it very well. But let's say you have a front end, some front end web servers, then in the middle you have some sort of middle tier. Then behind that you have some SQL databases. You could actually put application security groups in place that say the web servers can talk to the business, the application servers, and the application servers can talk to the SQL databases. And that's it.
And so you've got that you've got multiple layers. I mean, that's defense in depth, right?
Yeah. And the whole point there is that if someone compromises the web server, they can't get to the data. The network traffic will not allow that. They have to go through the middle layer first. So application security groups are another thing on top of network security groups to help isolate or direct some of that traffic flow between VMs. It's a very useful technology, very useful. But not a lot of people actually know about it, which is kind of interesting. But anyway, there you go. All right. So when should you use network security groups? Well, the answer kind of is, all the time. Always. I mean, they cost nothing. They're a very easy to use, very easy to debug when things fail. Technology which can be used to really isolate your environment. So you should always be using them.
And they are super easy to use. They're not massive overhead. And there's a lot of value, and they're free. So no excuses. No excuses. Exactly.
So let's go look at a quick exercise. So this exercise, I'm going to be honest with you. So this exercise is actually available in the actual learning path. It's available online. So let me sort of bring that up real quick. Where are we? Over there. Here we go. So this is the learning path. I'm going to stay on this page, by the way. So we're actually at this at the lab right now. Now, this is interesting. You can experiment with all of this stuff by going to the learning path, and then you'll get to this lab. It's a little exercise you can do. And when you activate the sandbox, that's going to be your own little private environment in Azure. It's free, and you can now start experimenting. So the examples that we've given here are all using the Azure CLI. So I can go copy and paste.
We make it really nice and easy, nice and easy for you to. So if you're like we said at the beginning, if you're completely going from scratch, this is just like step by step by step. So you can learn about, you don't have to try and build something yourself to try and learn about it.
I mean, you can actually take all this stuff if you want, just change the resource group name. So this resource group name is basically a random resource group. It's unique to your environment. But then you could actually take all of this stuff and just apply it to your own environment. So, copy and then paste. And then, so that's creating a resource group. And then while it's doing, then I'm going to create, create all this other stuff. So there's the JSON representation of what I just created, and so on and so forth, and create VMs and then check connectivity. I'm not going to do that. I'm going to do something a little bit different just to keep things simple. I actually have.
This is a very kind of kids TV moment, Michael, when you've got to say, here's one I made earlier.
Yes, that's right. It's exactly. It's like Blue Peter, right? Here's one we made earlier.
Exactly.
So what I've got here is I've got 3 VMs. I've got Ignite A, Ignite B, and Ignite C. And I apologize if you can't read them very well. I realize this is actually using Azure Bastion. These VMs are not publicly accessible at all. So I'm using Bastion to get in there. They're all inside their own VNet. So they have their own virtual network. And inside of that, 3 subnets. One of them is for the Bastion host, and the other 2 are for the VMs. I've basically got one.
What is Bastion, though, Michael? Just in case anyone's listening.
Bastion is like,
know what it is.
Yeah, so it's a way of connecting to a backend system without exposing the system. So you actually connect to Bastion, and Bastion connects to the system you're interested in. So the name comes from the old, Bastion host, right, which has been around in networking for a long, long time.
Or if you're from my part of the world or some other parts of the world, you may know it's a jump box as well.
Yeah, jump box. Yeah, it is, but it's something that's hosted in Azure by Azure. And the nice thing is that you can actually see it, in the browser if you wanted to, or you can run it from the command line as well. So very highly recommended because you're not exposing your your virtual machines to the internet. So I've basically got 3 virtual machines here, and you can actually see if I look at their IP addresses, ifconfig. So this is 10.0.0.4. This one is 10.0.5, and this one's in its own subnet. This one is completely different. It's in a different subnet. it's in 10.10.24. So that's 10.10.04, 10.10.05, 10.10.24. So from 10.10.04, I can go ahead and ping 10.0.0.5, which is, oh, whoops, helps if you got the IP address right.
Oh, it does. Yes, it does.
Yeah, it's really important. And
I
now
was
what
going to
I'll do
say,
is
I don't think it's pinging, Michael.
that doesn't seem to be working. So 10.10.0.4. So I'm now going to ping backwards.
So we're pinging each other on
We're now
those
pinging
two
each other. Yeah, right.
servers.
Pinging each other. So everything's golden there, right? And
Yeah.
then from this machine over here, I can also, I can also ping the other machines if I wanted to as well. But let's just ignore that for the moment. Now, here's where things become really interesting. So if I actually bring up that to go to, here's my resource group, and here's my VM. So that I'm looking at the configuration information for this VM right here. And if I go to networking, here is the NSG.
And we can see all those default rules that we talked about.
Yeah, and the only one that got added in here is this SSH one, because when I configured it through the portal, it said to me, hey, do you want to use SSH? And I said, yeah, sure, why not? And so it's allowing SSH in there. And it's just kind of warning me because the source is any, or the source is any, I should say. And it's going, hey, that's the internet, just so you know, mate. So the source is any. But here's what I'm going to do is, so A is pinging B, and B is pinging A. And as you can see, hopefully you can see it, it's sort of sliding by here slowly. So up to sequence 67, and over here, sequence 77. Yeah. Now I'm going to add a new rule that's going to block the traffic, the ICMP traffic going into VMA. So I'm going to say source, yeah, anybody, source port, don't care. I'm going to say I want to use ICMP. And I'm going to call
the ping protocol.
That's ping, yeah. And I'm going to say block ping, and I'm going to say deny. Now watch this. I'm going to apply that. It's creating a security rule. Now it takes a few seconds for the actual rule to come into effect, but you'll see it coming in a moment. Okay, it's created it. So I've gone, there's my outbound rules. There's my inbound rules. Let me go and refresh that. Networking, and there we go. So block ping. Okay, here we go. Now what's interesting is that A is still pinging B. They're still chugging away, 139. And B is still pinging A right now. So in a moment, that should just come to a dead stop. He says, hopefully.
But sometimes things can take a little bit of time.
Oh, hang on. Did I actually apply that?
Did you apply it, or did you just save it?
No, I applied it.
It's there. It's there. Oh, Michael, the demo gods are not behind you, possibly.
They're not. Let me have a look at this. That's interesting.
Now we're going to do
there we go.
It
stopped. Okay, no, it stopped. Here we go.
Oh, there we go. There we go.
If you look down the bottom, it's stopping at 157, but in the other direction, it's still going.
So sometimes I guess that this is actually a good demonstration of when you provision things in the cloud. It can take, and it depends on what it is. It can take a couple of minutes, 5 minutes, 10 minutes. Not for something simple like an NSG role, that should be fairly quick. But it's not immediate when you see it in the UI, which is what we've just seen there. So
here it is. So it's dead, right? It's just completely stopped. There's no more traffic moving at all. But this one is still chugging away. And then what I can actually go and do, and I realize I'm just really, getting ready to annoy the demo gods here. There's the rule. And I can actually just go and delete that rule now. Which one was it? This one? This one right here.
Second one down. Second one down.
And then save it. And in a moment, whatever that means, we'll see this actually. It's kind of interesting. Oh, there we go. It picked up. It started again.
Oh yeah, you can see the change. You can see the gap in the sequence as well.
So there's A to B, and B to A is now picked up again. And there we go. So here's the gap. Here's the gap right here, 157 to 222. Right. So there was a whole bunch of dropped ICMP packets. So that's an example of applying one at a NIC, which is what I did. Because I went to the VM and I looked at its NSG, which is basically going to apply it to the NIC. So that's actually really, really cool. Very simple. I could have done it at the subnet level as well, but I just want to keep it nice and simple, just for keep it simple.
Yeah.
All right. That is a quick look at NSG. So basically what we did is, even though the example, so if you actually do the one that's actually in the lab, or in the learning session, it will actually do something a little bit different. It will use HTTP as opposed to ICMP, but honestly, it really doesn't matter. I just wanted to keep it
No,
nice and simple. But
I mean,
essentially, what we did is we
it's essentially
blocked.
protocols and port numbers we changed, right?
Yeah,
That was
yeah. So this would have been, if I was to block HTTP, it would have been port 80, right, on TCP. Whereas in our case, we just blocked ICMP, but it's exactly the same result.
Speaking from a security perspective, we should be blocking HTTP because I would hope that something was using HTTPS, which is
yeah, you're right. That's for 99% of the scenarios.
Yeah,
you're absolutely right. But what we ended up showing just then was basically allowing ICMP in one direction, but blocking it in the other direction rather than HTTP. So the actual lab that you'll go through, which is what I showed you before, you would create the VNet and the network security group. You would then create the VMs, and then you would do the connectivity between the two of them, or not. In that example. So that's kind of network security groups, incredibly powerful. They are an absolute cornerstone of any networking environment within Azure. They're certainly a core starting point. So let's change our attention now to PaaS service, like securing PaaS services with virtual network service endpoints. Now, this slide is probably the most important slide of the lot. What it essentially does is extends your VNet to be accessible by one or more PaaS services. So what you essentially do is you take the endpoint for a PaaS service, say, for example, storage, and you make that accessible inside of your VNet with an address that's basically as part of your VNet. And then what you do is you turn off public access first, I should say. You turn off public access first, and then you essentially inject the VNet, the PaaS service into your VNet. And now I can access that particular PaaS service, so for example, a storage account or Cosmos DB, using a private IP address. But under the covers, Azure will actually route it to the endpoint, the PaaS service endpoint for you over the Azure backplane. So the traffic never goes on the internet. I've seen some people, take an environment and route traffic to their on-prem firewall and then route it back out to Azure. But obviously that's got latency written all over it. But that's what people used to have to do in the past before we had service endpoints. But now we have service endpoints that help alleviate a lot of that.
So just taking a step back, Michael, because I remember that when I first started learning Azure, which was a while ago, this sometimes, and doing cloud stuff, this sometimes confused me a bit. So when we talk about PaaS, we're talking about things like Cosmos DB, log analytics, any PaaS service in Azure. But by default, they have public endpoints, right?
They all have public endpoints.
They all have public endpoints. So normally that's what you'd be hitting. So this is a way of communicating with those PaaS services, but not having to hit the public internet, right?
Correct.
Yes,
correct.
Because this is, really I know this is actually something that I personally struggled to get my head around for a little bit of a time. So that's why I wanted to labor the point. And for those of you who are watching, just in case you were also struggling to follow what was going on, it took me a little while to get my head around this concept. But remember, when you use a PaaS, by default, the traffic will hit the public endpoint. So, and not everybody wants that, right? So this is a way of not going out to the public internet to communicate with PaaS.
Yeah, but I want to point out something. There is still a public endpoint because it's still a PaaS service. So there is still a public IP address. But the thing is, but the traffic goes over the Azure backplane. And so essentially what it does is it will take, so your VM will go and hit like a public endpoint, like a storage account.
Yeah.
Under the covers, Azure will actually look at that address and say, oh, hang on a minute. There's a route for that particular set of IP addresses to this private IP address instead. Yeah. And that way it stays within Azure. It doesn't go over onto the internet. But there are still public endpoints because at the end of the day, storage account still is accessible over the internet. But you're restricting access to your specific endpoints to keeping the traffic on the Azure backplane. The list of virtual network service endpoints is here. These are the products that all support today service endpoints. And there's container registries and public preview as well. And over time, this will grow as well. The nice thing is a lot of the tools that are in my backyard, like SQL Database, Synapse Analytics, Postgres, MySQL, Maria, and Cosmos DB, they all support service endpoints. There's an interesting little caveat at the very top here, which I really want to stress. So the nice thing about service endpoints is they're very easy to configure, very straightforward, and they get the job done. But you still have a public IP address, and you also cannot access the service from on-prem. You can't go directly to it from on-prem. You can't use like a private IP address. If you wanted to do that, we have to use what are called private links using private endpoints. That is, as I mentioned earlier, we're not covering private endpoints. That's a whole nother discussion. But the recommendation for the most part is to use private endpoints. But you still have to kind of know what service endpoints are, if for no other reason than to sort of compare and contrast between the two.
Yeah, and this is like I said, I think if you're new to Azure and you're new to this sort of stuff, I realize like this is a bit like, what's the difference? I don't follow it, but like there's more learn modules on private endpoints. Yep. Please ask more questions in the chat if we can clarify for you. And of course, there's plenty of Microsoft community places in our tech community. You can ask questions if you're struggling as well. Because I know like this one's dear to my heart, that I struggled to understand the difference to start with initially.
Yeah, agree 100%. I think a lot of people do. It's, but the key thing I think is this slide here. If I go back, is this directly extends your VNet to one or more PaaS services. So what that means, if you've got like a 10.10.0. whatever, you will be able to access a storage account using essentially a private address. The public address doesn't go away, and it's not. In fact, one of the first things you need to do is actually turn off public access for your specific, say, storage account, for example. But there are still IP addresses that are publicly accessible. It doesn't mean people can access your service, but there are still public IP addresses. I really want to stress that because it's a PaaS service, but you're now accessing it using private IP addresses, so the traffic stays on the Azure backplane. And what's really important is that your VM might access storage using its public IP address, but under the covers, we will actually accessing it using the private IP address instead. As part of essentially an extension of your VNet. And that's probably summed up in this, and I think nicely in this image. So if you've got, say, a web server and a database server, this could be, let's just say this is a VM, and this is Azure SQL DB. It could be a VM. But Azure storage is PaaS, right? So it has public IP addresses. Essentially, what you're doing is you're injecting a service endpoint into your VNet that has an IP address that can be accessed privately by all these entities inside here. So the web server can access this IP address. What's cool is that the web server is probably using the will probably be using the public IP address to access the storage account, but it will be routed on the Azure backplane using a private IP address because you're injecting this service endpoint into your VNet. And so this service endpoint right here will actually have like a 10.10.0.6, for example. Now you may access something with a 23.5.7.3, but under the covers, Azure will automatically route it to the private endpoint instead. It sounds a little complex, but I think this is probably the most important slide. Essentially what we do is we take Azure storage and we say, this is a private IP address in my VNet, and now you can access it. And the net effect is performance and security, because you've turned off public access to your storage account, and now it can only be accessed this way. But the IP addresses, the public IP addresses, are still there because there are millions upon millions upon millions of storage accounts, right? We can't just turn an IP address off easily because we're going to block a whole bunch of people. So when you create a service endpoint, the first thing you need to do is turn off public access to that service. So you go to the storage account and you turn off public access. That's the first thing you do. Then on your virtual network, you actually add the endpoint for that particular service. So for example, a storage account. This is what it ends up looking like. If you look at, this is called the This is the default route. So when a service makes a request to communicate with some IP address, it needs to know, well, where does that communication go? So if you're making a connection, as an example, let's say you have a VNet that has this CIDR range, this address range, like a block of IP addresses. So let's say you want to make a request from your VM. It's in this VNet. It makes a request to 10.1.1.7. The route for that particular VNet will, or for that particular environment, will say route it to the VNet. The next hop is the VNet, which means that it can communicate with anything else within the VNet. This one here says if it tries to make an outbound connection to like basically anything, then that goes to the internet. And then there's all these other ones down here as well. Now, what's interesting is when you add a service endpoint to your VNet, saying I want to talk to storage accounts on the backplane, this is what it ends up looking like. So we saw those things that we saw before, but now see these other two ones down the bottom here. Well, that's kind of interesting. I wonder what they are. So if you want to work out what actually happened here, it's actually pretty straightforward. You take this address, that address range, and you go to your list of, where are we? They're in here somewhere. There we go. This list here. Search for that IP address. So what did you say it was? 20.38.106.0.
106.0.
Oh, it helps if you get it right.
I thought, yeah, it does. Yeah,
oh, look at that.
Storage UK South.
Storage UK South. So basically what we've done is we've said, if my code, my solution is going to access a storage account in UK South, then it's actually going to route that request to that public IP address. It's going to route it to the virtual network service endpoint instead, and then it will actually route it on the Azure backplane to the Azure storage in, what did we say it was? UK South.
UK South. And you can see as well there that it also says 10 more, and that's, I assume, the other 10 that you were just on your list there as well.
Look, there we go. There's a whole bunch more.
Yeah, it's all of those.
Exactly. And it's probably, well, that's one range.
Yeah, that's one range, yeah.
There's a whole bunch of them, whatever that one is, and there's 9 more of those. So yeah, so essentially what you do is when you add this this service endpoint, so this is really important, is you're saying, okay, if you're like, say, a VM inside of a VNet, and it wants to touch, in this case, a storage account in UK South, it will actually say, okay, route that request to the virtual network service endpoint, which is on the Azure backplane. It's a private IP address. Then the traffic will actually go, it will not go across the internet. It will go, directly to that, that data center, not over the internet, through the Azure backplane, do all its work, and then bring the results back. And it will never go off the Azure backplane. So you don't just get security and some more isolation from that. You also get performance, right? Because you're not going over the public internet. You're staying on the, in fact, it is the most optimal route by a long shot. So that's essentially what that does. We can see it kind of in action if we do it real quick. How much time do we have? Ooh,
we have 12 minutes, Michael.
Okay, let's try and get this wrapped up without breaking too much. So here I have my resource group. Let's go back to the resource group, and we'll go and look at the various virtual networks. So I've got one virtual network here. I'll bring that up. And we have, inside of that, we have various subnets. And so we have this one, let's say default 2, right? Which is the second one. I couldn't come up with a better name. So, but if you look, that's actually what this particular VM is in. Like if you look at this, this IP address, right? It's actually in this subnet. It's in this subnet right here. So what I can do is I can go and look at the service endpoint. Like I say, in this particular thing, I'm interested in Cosmos DB.
Yeah.
Right.
And so we don't even have to know the IP address ranges or anything. We just pick the name of the service.
So I'm going to save that. We'll get there eventually. So what it's essentially doing now is adding this route to the route table. So give it a moment. I need to get this all done. But while we're there, let's just go back. While we're waiting for that, let's just go back to. Oops. Whoa. Did I click on save? Yeah. Let's just wait for this to finish.
Yeah, I think it needs to finish before you move page.
I don't want to do anything bad. But essentially what we're going to do is we're going to add a Cosmos, there we go. We're going to add a Cosmos DB range. So let's go back to test. And let's bring up a virtual network, virtual network card. Let's do this one. So this one here is actually the network card, network interface card that's actually on this VM. Oops. So I'm going to click on that. And I'm going to look at effective routes. This does take a little bit because it's got to go and enumerate everything. I swear this was faster last time. I swear it was.
That's because we're doing it live now, Michael. So
now look at this. Look, so here's a whole bunch of other stuff, other bunch of mumbo jumbo, including a whole bunch of stuff that's being black holed, right? Look at this. Ooh, that's interesting. So if this VM or anything that's listening on this network card, or more accurately, the subnet, I should say, subnet, not network card, but subnet. But I'm looking at the network card that's actually on that subnet. You'll see that it's saying that anything to 207.46.150, blah, 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 and 40 more, then route it to the virtual network service. So it's actually going to do the service endpoint stuff. Let's go and look at, remember it was Cosmos DB. Let's go and look up this address. So 207, where are we? There we go. 207.46.150.252.
Oh, there it is.
Look at that. In fact, it's Cosmos DB. It was Cosmos East Asia.
Closer to me then.
Yeah, actually, that's one of two. So what's this one? This one's probably just Cosmos DB.
Oh, Michael, we have a question whilst you're having a look at that. We've been asked, do we need to add the client IPs to the allow list for the NSG service endpoints to route the PaaS traffic through the Azure backplane?
So service endpoints. So the answer is, let me make sure I get this right. If let me give you a very brief answer, and that is if your solution involves private IP addresses like on-prem, you need to use private endpoints. You need to use private link, private endpoints. So private link is the technology, and private endpoints are like the deliverable, so to speak. So the answer basically, if you want to do that, like you want to do on-prem kind of stuff, you have to use private endpoints, and let's just leave it at that.
Cool.
Now, actually, one thing I will point out, though, is that historically, when private endpoints first came out, they did not support user-defined routes, and they did not support NSGs. But that was actually fixed, I think, like the end of last year. So they now support NSGs and user-defined routes as well. Yeah, but yeah, if you're doing anything like on-prem, and you want to access something using a private IP address, using like on-prem private IP addresses, you have to use private endpoints. Now, the reason why we have these service endpoints as well is they're way simpler to configure and provide a good degree of network isolation, but you still have a public IP address. Not that anyone can do anything with it, but it's still there. With a private endpoint, you end up having private IP addresses. The problem is they're a lot more complex to configure. The biggest issue with private endpoints is network security groups. You really have to start, DNS resolution. And with service endpoints, you don't need to worry about any of that kind of stuff, which is actually really, really nice, but it doesn't provide the same degree of isolation as private endpoints. And honestly, that's why private endpoints kind of have their own learning path, because it's a whole separate technology that's a lot more complex. But if you want to get sort of, to a degree of network isolation, this will get you there. Like service endpoints will get you there. But if you want to get like really locked down isolation, you really need to look at private endpoints, but it's more work. So I'll tell you right now, I know some customers who require certain payloads, certain kinds of payloads. So for example, healthcare. I worked with some customers who, had healthcare solutions that we deployed. They required private endpoints, which meant that there was a subset of Azure PaaS services that they could use, which is fine. It turns out that the services they wanted to use had private endpoint support. But for other workloads, they were happy to have service endpoints because it's easier to configure and a lot less complex.
And one more question on service endpoints, because we're getting some questions and we've only got 6 minutes left. But do service endpoints add any expense to your resource group? I do not believe they do.
Well, no, they're actually a resource. They're actually a resource in your subscription. Yep, they're actually a real resource. Yeah, you can actually go in. Yeah, you can edit them. You can modify them. Just like say, I don't know, a public IP address, right? A public IP address is something
But do we charge for them?
No, they're not charged for. No, we don't charge for
That
them.
was
No,
the
no, no,
sorry,
we don't
that was the
charge for them.
question, Michael. I
I'm
didn't think we
sorry.
did.
No, we don't charge
And
for
then
them.
one more question, and then we should probably just show the because we are I knew you and I would be pushed for time.
Yep.
If we use service tags like Azure Active Directory, Storage, .Australia Central, or Azure Backup, do we actually need these if we use the service tag internet, or are they all considered part of the internet tag?
No, internet is basically like everything. So
Yeah.
no, you need to be using service tags. Yeah.
Yeah. Okay. So we've got 5 minutes, Michael.
Okay.
Because I'm going to be timekeeping lady.
No, I know you are. I know you are. So
yeah.
I just want to point out real quick. This is kind of what it looks like. If I have a storage account, one of the first things I do, and it's just an example, and honestly, storage accounts are probably one of the simplest examples and really, really simple to use. So we always use those as the example. The first thing you would do with a storage account is you would say, deny internet access. That's the first thing you would do. Mm-hmm. So that means if this app service tries to communicate over the internet to that storage account, it will fail, absolutely fail. Then what you do is you create a service endpoint, and that service endpoint will then be injected into your VNet, and that will become an IP address. What's really nice here is that this server over here will actually access this endpoint, and it will go to the storage account, but it will all go across the Azure backplane. So that's kind of what it looks like if I was to sort of, paint a picture. Now, the learning path actually includes a full lab for this. They said that lab from beginning to end, the whole learning path takes 45 minutes. It's not 45 minutes, I can tell you right now. So that I could feel, the same, pain that you would feel. I actually went through and did the labs as well, just to double check. And it's more like an hour and a half. So set up an hour and a half for doing these labs. But they're well worth it. They're actually relatively straightforward to set up, and certainly if you just copy the the text that's on the the Azure CLI scripts, it's pretty straightforward. But again, the key thing with an Azure service endpoint is you're essentially injecting an IP address into a virtual endpoint into your VNet, and remember, a VNet is an isolation boundary, and now your services can access that endpoint. And the communications to in this case, Azure storage will all be over the Azure backplane, and there is no public access to your specific storage account, none whatsoever. So a quick wrap up, because we're really close to the end of time. We will literally get yanked off stage at the top of the hour.
We will.
This is the kind of what the learning path says. You will identify the capabilities and features of network security groups. That is absolutely true, but by the same token, I would experiment with NSGs. It is one of the most fundamental defenses that we have in Azure. Again, you can apply these things at a NIC, like a virtual NIC, so on a VM, or you can apply it at a subgroup, a subnet. Either works. The recommendation is subgroups, subnets. Next one is network service endpoints. Again, you're essentially taking a publicly accessible endpoint, let's say storage account or Azure SQL database or Cosmos DB, and you're allowing it to be accessed using a private IP address that's actually on your VNet. But the first thing you need to do is cut public access to your resource, so no one can get to it, that way. And anything on that VNet will now actually access that IP address, and it will go to that particular endpoint. So whether it's Azure SQL database or storage or Cosmos DB, and hopefully it became obvious what's going on when I showed you the routes, and then looking up the IP address ranges in the list of the list of Azure public IP addresses. Then we showed how to use NSGs to restrict network connectivity. Again, there's sort of inbound and outbound TCP, UDP, port numbers, IP addresses, including IPv6, and then also the fact that you can use these service tags. If you want to communicate with a specific service, you can restrict access, or even in a specific region. So storage South Central.
Michael,
yeah.
Quick.
Yeah.
Last point.
Yeah.
We need to wrap up, otherwise we'll get cut off.
Okay. So for more info, here's where to go.
Yeah, more info. Please go do the Learn Live. Please go do the Learn Live module. Well, go do the Learn module. You can find it here. We have the links.
Yep.
Obviously, thank you all for joining us. It's been really good to talk to you all. Hopefully you found this interesting. Michael's done most of the talking, but that's fine. As you can see, my lovely dog has really enjoyed it in the background here. So Mina's loved it.
All right. Well, and again, thanks to all of you for tuning in. If you have any questions, you know where to find us. And yeah, go and do the actual learning session. It's actually really straightforward. It's actually a lot of fun, to be honest with you. And with that, I think we are completely done. We're out of time.
Yeah.
It is.
And thanks very much, everybody, and have a good rest of your Ignite. Happy Ignite. Bye.
Take care. Thanks, guys.